Hello guys, and what's up? My name is Abram and welcome to our Maths on Monday. I hope you enjoyed your maths though at school. We're doing a show for you guys as grade 12s. We know that you need this. It's going to be a great revision, and we're not alone. We are with Sithe. Sithe, how are you?
I'm good, sir. How are you?
I'm doing well, sir. What are we up to today?
Mathematics as usual. But tonight we'll be looking at your differential calculus, yeah.
Nice one. It's going to be a great show. I can feel it.
I feel it myself too.
Nice one. Well, guys, all you need to do to join our show, it's simple. Go to facebook.com/learnextra. Like our Facebook page, tell all your friends about it, and make sure that they come in, engage, and help one another on our page. Also, follow us on Twitter at learnextra. I am a nice guy. I've posted the notes for you, so it's simple learning with this. The notes are also what Sithe is going to go over. You can get yourself this workbook for only 139 Rand. Simply send an email to sales@mindset.co.za. It's going to be a great show. There's fun stuff coming through, competitions for you guys, and more links. So do check out your Facebook and your Twitter. Sithe?
Thank you, Bob. Okay, guys, let's get started with your differential calculus. But I just want to go back and explain some of the things that that we're looking at in your calculus. Okay, so here I've got a parabola with negative a, and then I've got a line there, and I need to speak to you about these words. I need to look at your gradient, your secant, your tangent, and your average gradient. If now, for instance, if we look at this line, okay, right, from grade 8 and 9, we can work out the steepness of this line, right? So that is your gradient. So what we can do is, to work out the gradient of this line, we say like the change in y over change in x. So that formula y2 minus y1 divided by x2 minus x1. So that is your gradient, the steepness of that line, and it can be very steep or not too steep and so forth. Okay, right. But now when we, for instance, take this line and we move it a little bit, right? If I move this line and it touches maybe, for instance, just one line at that curve, right? We call this line a tangent, okay? All right, you've got it on your notes. That will be your tangent, right? Now, but if I continue with this line and maybe pull it a little bit in there, and then I'm now meeting the graph in 2 points, okay? So there's this point here, and that point, say this is A and that is your B. And now if I'm joining that line and I'm cutting the graph in 2 points, then that is our second, all right? So now if that would be our second. Now if I can ask you to find the average gradient of this graph here, what you can do is between these 2 points, all right? So you can have a point there, for instance, that can be maybe 4,5, and then your y, maybe it's 4, and then your x here can be 2,1 and 1. So you can work out your average gradient between those 2 points the same way you've been doing in grade 8 and 9, that this is a change in y over change in x, okay? Right? We'll come across these words when we're doing, we continue with our calculus, all right? Now, so if we look here, if I'm coming from this side, approaching 5 from the left-hand side and approaching 5 from the right-hand side, what is my output? What is y here? So the y will be approaching a certain value there, which is just above 4, which may be 4.1 or something. So that is your limit, okay? So I'm approaching that 5 from the left and also from the right, and then I'm getting the same value, so the limit does exist there, okay? Right? And then, now, guys, with your calculus, we'll be talking about you finding the gradient of different functions, okay? So now they'll be talking about first principles, okay? So when you need to find the gradient or your derivative from first principles, now for instance, I have a graph here, all right? Okay, and there's a point there and a point there. This is your x, and that is your y. For instance, if this point here, I've got A, and then this may be A plus, say, H, okay? So this graph is your f of x, all right? Now, what is our y value there? What is y at that point? So it will be f of a, right? Because our a is, our x is a there. And then this here, I'll have f of a plus h, all right? So now we can work out the average gradient between those 2 points, okay? So now our gradient will be change in y over change in x. So our change in y, that will be your f at a plus h minus f of a divided by your a plus h minus a, and then you can simplify that to your f of a plus h minus f of a all divided by h. So now when we asking you to find the derivative or your gradient from first principles, you have to always remember that you'll be using a formula, and our formula is your f prime x, the limit as h tends to 0, okay? I need to just fix that. So it will be your f prime x, okay, equals to the limit as h tends to 0, gets more closer and closer to 0, of f of x plus h minus f of x all divided by h, all right? And then we'll be talking about finding your derivative using rules, okay? So now, for instance, they can ask you to find dy dx. If you are given, say, x cubed plus 2x plus 5, now you'll be asked to find the derivative with respect to x. Now, if they're asking you to find dy dx, your y has to be the subject of the formula, and you must have your x. Now, the rule here, when they're talking about finding the derivative using your rules, for instance, if you are given f of x, right, equals to x to exponent n, right, your rule of finding this gradient of that particular curve, can you see now what we're going to have here is f prime x. Now when you're finding your derivative, the notation changes. So this is what you're going to do, that it's your exponent times your coefficient, right? So it's going to be 1n times x to exponent n minus 1. So that is your rule in grade 12. For instance, if I give you f of x equals to maybe 3x to exponent 4, and I'm asking you to find the derivative using the rules of your differential calculus, then this is just a function of x, all right? So to get your f prime x, you'll take your exponent times the coefficient, then you have your 3 times 4, which gives us 12x, subtract 1 from your exponent, so you get 12x to exponent 3, right? So we'll get to that as well, right? Although you have it in your notes, but what I want to stress is that when you're finding your gradient or your derivative of whatever function they're giving you, finding the derivative with respect to x, please make sure that you have your x, it's going to be x to exponent something, x to exponent something. Your x must not be the denominator, all right? So you have to simplify first. Your x may not be under the radical sign, and if you've got brackets, factorize first before you work out your derivatives, okay? So we don't want to see brackets, we don't want to see sets, and no variables in your denominators. Okay, right. Abram,
Yes?
you can talk to them.
Okay. It's time for a break already. I was still like enjoying the lesson. Well, guys, I think you do deserve that break. We'll have a special competition for you guys where you can win yourself 1 year of free accommodation. All you need to do is simply fill in the entry form that we have for you on Facebook. We'll see you after this. Welcome back, awesome mathematicians. Now, I've got a question on our Facebook page from Lutando Tido saying, how can a person get the maths videos and notes? Guys, it's simple. If you miss any of our shows or if you'd like to get in touch with us and see our schedule, go to lan.mindset.co.za. It's simple, guys. Or visit us on facebook.com/LearnExtra and ask us. We'll send you the link. There are a couple of comments that I'd like to go over. Khutato saying, hi, guys. I'm watching with my whole family. Excited that you guys have finally started with calculus. Khutato and your family, a big shout out to you guys.
Hey, Tada.
Sure. A last one from Tepo saying, hi guys, I'm watching the show. Just want to send a shout out to my friend Yamkela. A big shout out to you guys. I hope you're learning more and learning extra with this. Back to you, Sitha.
Thank you. Back to calculus, guys. So now we are finding the derivative from our first principles, and then we said, okay, you need to use a formula when they're asking you to find from first principles. And now, let us remind each other of the formula. We said it's f prime x equals to the limit as h tends to 0 of f of x plus h minus f of x all divided by h. Now, guys, watch. Before you do it, please use the rules first and check what's going to be your outcome, all right? So we said our rule before the break. We said this is going to be your f prime x equals to. Now we take the exponent times the coefficient. Minus 2 times 2, we get minus 4. X to exponent 2 minus 1. Then our final derivative will be minus 4x to exponent 1. So that's your f prime x. So whatever we are doing here, at the end of the day, we must get minus 4x. Right. So now, let's go through it slowly. Okay. So we have the limit as h approaches 0 of f of x plus h. Now, this is f of x. Now, when we're talking of f of x plus h, where I see x, I'm going to sub in the x plus h. So we have minus 2 bracket. Now, there is x there, okay? If you look at this, there is x. So in the place of x, I'm going to sub in the x plus h. And then I will square that because you've got a 2 there as your exponent, minus. Now, guys, remember to put a bracket here, minus your f of x, that is minus 2x squared all over h, right? So now we move on. This is the limit as h tends to 0 of minus 2, right? Now we have x plus h all squared. What does that mean? You've got x plus h times x plus h, all right? You multiply that out. You get x squared plus 2xh plus h squared, right? Now, we come here. When you simplify, you've got your negative times a negative. You get a plus 2x squared all divided by h, right? So now next, this simplifies to the limit as h tends to 0. Guys, if you look here, you've got a minus 2 outside the bracket, right? Let's go back to grade 4. Bodmer's rule. Okay, remove your bracket, and then this is your distributive law. So it means that I'm going to multiply that minus 2 by x squared, that minus 2 by 2xh, that minus 2 by h squared. So what do you get when you multiply minus 2 by x squared? You get minus 2x squared. Now if you multiply minus 2 by 2xh, you get minus 4xh. And then the minus 2 times the h squared, you get minus 2h squared plus 2 x squared, all divided by h. Now, guys, when you get to this point, you go back, you check what was given, okay? So your function, you look for that function here. Whatever is given to you, it must cancel out, all right? So in this case, we were given minus 2x squared. I go and look for minus 2x squared. There is minus 2x squared plus 2x squared, okay? Right, so it cancels out. And then our next step, you'll have the limit as h tends to 0. Now, guys, when you get to the next step, you must always take out your common factor, h, so that that h will divide that h, okay, which is our denominator. So I'm going to have h bracket. If I take out h, minus 4xh divided by h, I get minus 4x, right? Minus 2h, all divided by h. Now, guys, watch what happens. The h divides the h. And we are left with the minus 4x minus 2h. Now, it says as h gets more closer to 0, okay? So h approaches naught. So this, if we were to plug in that h equals to naught, then our final answer will be minus 4x. So your f prime x is minus 4x. And you can see now, here, we had that limit as h tends to naught, limit as h tends to naught. But when you get to our final answer, this is like substituting with that h, which is getting more closer and closer to 0. So minus 2 by 0, then you get a naught. You're left with that minus 4x, which is our final answer. Okay. Right. Now, the next problem, it's also asking you to find your derivative by using first principles. But I'm going to give you this problem. You do it at home, all right? So, but then first of all, what I'm asking you to do is you find the derivative using the rules, and then from there you do it following all the steps of your first principles, okay? And then we'll look at it later. Now, question 2. They're asking you to find the limit if they do exist. Now, the first question, they're saying, as x approaches 2, does that limit exist? Okay? So now, if we watch here, as x gets more closer to 2, if I sub in a 2 there, I'll get 2 squared plus 3 bracket 2 plus 2, all divided by 2 squared plus 4 by 2 plus 4. And that gives us 4 plus 6 plus 2, all divided by 4 plus 8 plus 4. And then that's 12 divided by 16, which can simplify to 3 over 4. So this one works perfectly. But now, if you look, when you're doing your limits, if you check with your denominator, okay? So what you need to do is you factorize, okay? So this is your limit as x tends to 2. Can you factorize x squared plus 3x plus 4? Yes. This will be x plus 2 bracket x plus 1, all right? This is all divided by. Can you factorize x squared plus 4x plus 4? Yes. That is x plus 2 bracket x plus 2, okay? Now, the x plus 2 divides the x plus 2. Then you are left with the limit as x tends to 2 of x plus 1, all divided by x plus 2. Now, as x gets more closer and closer to 2, then we'll have 2 plus 1 divided by 2 plus 2, which gives us 3, all divided by 4, which is 1 and the same thing. Okay. But now, at times, it can get complicated. If you look at your question 2, they're asking you to find the limit, okay? The limit as x tends to minus 1. Now, if you look at this problem, if I were to do it like the first one, I have, this is x tends to minus 1. If I were to substitute here with minus 1, that is squared minus 1 over minus 1 plus 1, okay? Whatever you get at the top, But if you look at your denominator here, you get minus 1 plus 1, and we all know that we're not allowed to divide by 0. That will be undefined. So now that is why I said to you, you need to factorize first, because you're avoiding this thing of dividing by naught. So the notation still stays the same. The limit as x tends to minus 1. Can we factorize x squared minus 1? Yes. From the difference of two squares, so this is x minus 1, bracket x plus 1, all divided by x plus 1, okay? Now, next, the x plus 1 divides the x plus 1. As you can see now, so we've got the limit as x tends to minus 1. It's getting more closer and closer to minus 1. And we can now substitute here. You get minus 1, which gives us minus 2. So in simple terms, the limit as x tends to minus 1 of the function x squared minus 1 all over x plus 1 is negative 2. Okay? Right. Now, we're going on to our question 3. You need to find the derivative of this function. One of the rules that we spoken about is in grade 12 level, okay? We don't want to see our x being the denominator, okay? So it's either you factorize, okay? Or if you've got a single variable as our denominator, for example, if you've got y equals to x cubed plus 4x squared minus 3x plus 1, this is all over x. Now, our x is the denominator. What you need to do here is, because it says all over x, so it means that each and every term has got a denominator of x. Okay, so you've got y is x squared divided by x cubed divided by x, that's x squared, plus 4x squared divided by x, that is 4x, minus 3x divided by x is minus 3, plus 1 over x. Now, before we find the derivative, your x may not be the denominator, so you can take this one up, so you get y is x squared plus 4x minus 3 plus x to minus 1, and then you can find your derivative. Now, let's come back to our example here. Can we do that and making everything out of x plus 2? No, it's going to be difficult for us to simplify. But now let's go back and check. Can we factorize at least? Yes. If you look at your x squared plus 6x plus 8, you can be able to factorize that. You've got f of x equals to x plus 2 bracket x plus 4 all divided by x plus 2. Right. Now, you watch the notation. It is still f of x because I'm still simplifying there. Then we get f of x equals to, now the x plus 2 divides the x plus 2, and we left with the x plus 4. Now, as we agreed earlier on that you must have your x, it has to be to exponent something. It must not be the denominator or under the square root or something like that. Now, this is f of x equals to x plus 4, right? This is your straight line. What is the gradient of this line? So now we're going to say this is f prime x equals to. Now we said, according to the rule, we take the exponent, we multiply by the coefficient, and we subtract 1 from the exponent. So this is 1 times 1, which gives us 1. X to exponent 1 minus 1, right? Now, if we look at this 4, all right, that's your constant. But your constant, your derivative will be 0. But how did we get that 0? This is 4 x to exponent naught. You take your exponent times the coefficient, which is naught, x to exponent 0 minus 1. So you've got 0 times x to exponent minus 1, which gives us 0. Okay, so now our derivative will be just x to exponent naught, which gives us 1. So anything raised to exponent 0 is 1. So that is your derivative of that function, x squared plus 6x plus 8 all over x plus 2. Okay. Now, question 3. You need to find the derivative of y equals to 3x squared plus 6x plus 2 divided by x. Now, we have to watch. Do we have x as our denominator? If you come here, there is x in our denominator. So what did we agree on? Is that we don't want to have x as our denominator, so you have to take it up. It must always be x to exponent something. So you've got y equals to 3x squared plus 6x plus 2x to minus 1. All right. Now, finding our derivative, now the notation changes. So you're going to have dy dx, right? Our y is a subject, okay? So we're finding the derivative with respect to x. Now you have 3x squared. How do I derive 3x squared? I'll have that exponent times the coefficient, first thing, 6, x to exponent 2 minus 1, we get 1. And then we move on to the next one. Your 6x, you've got a 1 as your exponent. So 1 times 6, you get plus 6. X to exponent 1 minus 1, which is 0. And anything raised to exponent to naught is 1. 1 times 6, you get a 6. Now we move on to this one. You've got a minus 1 times 2, which gives us minus 2. X to exponent minus 1, we get minus 2. So that is your dy dx, so your derivative with respect to x. But now if they asked you to leave your answers to positive exponents, so what you need to do, you look, you have a negative exponent, you can just take your x to exponent 2 down. So this will be your 6x plus 6 minus 2 all over x squared. So that is your dy dx. Now, we continue with finding the derivatives using rules. So you've got y equals to 5 all divided by x plus the square root of x. Now, we said we don't have to have our x as denominator, number 1. So you go and check. There's a denominator of x. We need to fix that. We don't want our x to be under a square root or your radical sign. There is our x there. So we're still going to simplify. Now, remember, the square root of 4 is the same as 4 to exponent half, right? So what we did in grade 10. Then you have, this is 2 to exponent 2 times half, and then you get a 2. So a square root of 4 is 2, but it's from your 4 to exponent half. There's an exponent of 1, and then there's a hidden 2 there. So, in other words, if I give you the square root of x, right? So there is a 1 as our exponent, all right? So you've got your x, there's a hidden 2 there, that will be our denominator, and so your square root of x is x to exponent half. But if, for instance, I give you the cube root of x squared, how do you simplify that? It's still the same thing, okay? Right, then you have, this is x, this guy is your denominator, 3, and then your exponent will be 2. So if you've got the cube root of x squared, before you find the derivative, you simplify it first. So that's going to be x to exponent 2 divided by 3. Now let's go back to our question. Right, we have y equals 2. Now we said this is going to be 5x to exponent minus 1, right? Plus your square root of x is x to exponent half. Now, if we look at our equation now, our x is x to exponent something. This one is x to exponent minus 1. That is x to exponent half. Now, we are now able to find the derivative. So we're going to say dy dx, okay, dx equals 2. Now, we go back to our rule. We said we take our exponent, we multiply by the coefficient. So minus 1 times 5, you get a minus 5. X, we subtract 1 from our exponent, so that will be minus 1, minus 1. And then we have a half times a 1, we get plus half, x to exponent half minus 1. Okay. Now, let's continue simplifying that. We get minus 5 x to exponent minus 2 plus a half x to exponent half minus 1. So it's the same as saying half minus 2 divided by 2. So we get minus a half. We can stop there if they didn't ask us to get it to positive exponents. But if they asked you to find the derivative and leave your answer to positive exponents where necessary, okay? Now, we then have to fix this. This is negative 5 over x squared plus half. You take that x to exponent half down, so that will be your square root of x. So this is your dy dx equals to minus 5 over x squared plus half square root of x, right? So now they will keep on changing the notation and so forth, but it still means the same thing. With this question, they can say, okay, find y prime. They're still asking you to find the derivative of that function. Okay. Right? Now, next. Find the derivative of that. You're given dx, so that's another name of finding your derivative with respect to x, okay? So now, we said we don't want x to be the denominator, and we don't want to have square roots and so forth. And where necessary, we need to factorize and so forth, okay? Now, if we look at this question, you've got a denominator of x squared. It must always be x to exponent something. So we're still fixing this, so that's why I have that dx bracket 4x squared plus 2. If you take it up, the sign changes, so you get x to exponent minus 2. All right. Now, let's just explain this thing a little bit. You've got 2 over x squared. There is x to exponent naught. Right? When you were in grade 10, you've got the same bases, and you're dividing. What do? You write only one base, and then you subtract the exponent. So this will be 0 minus 2. Then you get 2x to minus 2. That's why when you're taking it up, the sign changes. Okay. Now we can move on. From there, we have it as x to exponent something, x to exponent something. We can now work out the derivative here. Again, we follow the rules. This is 2 times 4, which gives us 8. X to exponent 2 minus 1, right? Now, this side, you've got minus 2 times 4, minus 2 times 2, minus 4, x to exponent minus 2 minus 1. Okay. Now, next, we simplify the exponents, so you get 8 x to exponent 1 minus 4 x to exponent minus 3. Right. So now, if they ask you to leave it to positive exponents again, you'll have your 8x minus 4 divided by x cubed. Okay.
Thank you, sister. I think we deserve a break. You're self-included on that one. Yeah. Guys, thank you so much for your questions and your comments that you've been sending through. If you're still struggling, we're here to help you, because every problem that you encounter, it means there's an opportunity for you to grow and to learn more. We'll see you after this break. Welcome back, awesome guys. Now, if you think you are that bright spark, enter the Be a Bright Spark competition. Winning is so easy. You could be driving off with that new Chevy Spark L, just like Dimaka to our first winner. So 3 more cars to be given away, and 1 could be yours. All you need to do is to buy yourself the Safeways K53 manual, or download the Cool Android app, which is available from Samsung Galaxy App Store or from the Google Play Store for only 59 Rand, guys. It's so affordable, guys. And then enter your details on our Facebook page, and you could be the winner. Your name will be on the draw. So all the best, and be a bright spark. Sitya?
Sure, Fitz.
I've got some comments here and questions.
Okay.
Are you ready?
Hoy them, yeah.
Okay, let's do this. Kate Hardy says, I'm watching the show and enjoying differentiation. Bunalo Klo says, this is my first time doing calculus. I hope to understand fully. I'll tell all my friends about it. Cam, here's a question from Sanil Dambo saying, what is meant by integration?
Okay. Guys, you're not going to do integration at school level, But if you are, maybe they're saying they're giving you f prime x equals to 3x squared. So they're asking you what was the, okay, this is your derivative, what was the function? So it's the undo of your derivative. So in simple terms, you go back to the function itself. So it was f of x equals to, because you were, what you did is you multiplied. So you're going to divide and then add, okay, the exponent. So this was your 3x2 plus 1, all divided by the new exponent, which is 3. So that was your x cubed. Now, this is the original function. Then they needed to get the derivative here. This is where we stop. They find the derivative. So this is 3 times 1, which is 3x to 2 minus 1. 3 minus 1. Then they get 3x squared. All right? So with integration, they will be doing it next year. So the undo of derivative. Okay.
Okay.
Yeah.
Awesome.
But it's not this year. Okay.
All right. Are you continuing? I've got another question.
Okay.
Okay. Actually, a comment before that one. Amrelang says, Abraham, please tell Mr. Siche that I wish he was my maths teacher, understanding calculus a lot more. Thank you, sir. Right. A question from Sandile Kumalo. Sandile says, if I've got y equal to cube root of 8x to exponent 18 minus 3.
Okay. Okay. Wait a second. If I've got y equals to
cube root of
cube root of
8x to exponent 18
to exponent 1/8
minus 3 minus 3 over 4x squared.
All over 4
x
x squared.
Yes.
Is he sure that it's 18 there? Okay. Right. Let's simplify it just a little bit. I need to explain something here. Let's say this is to exponent maybe 4. Okay? It's the same concept. Now, you said this is 3x all over 4.
It's, yeah, exponent 18 minus 3 over 4x squared.
Okay, minus 3 over 4x squared.
Yes.
Okay? This is actually a good question. Now, what we said, your x may not be under any set, okay? Right? So we don't want to see the cube root and the square roots and so forth, or the fourth roots, and then your x may not be the denominator as well, all right? So if we look here, there's x. Our x is a denominator here, and then it's also under radical sign there. So we need to fix that first. So you're going to have y equals to, right? That's 8, all right? That's the cube root of 8. You can just keep it that way. So cube root of 8, x to exponent 4 over 3, like I explained earlier, minus 3 over 4, and then you take that x up, then you get x to exponent minus 2. Now, from there, it is going to be easy, because now what the learner has to do, will say, okay, dy, dx, okay, the derivative with respect to x, and then takes the exponent times the coefficient, which is just a weird one here, cube root of 8 times the 4 over 3, x, and then you subtract 1 from your exponent, so you get 4 over 3 minus 1, and then you take your exponent times the coefficient, which is going to be a plus 3 over 2, x to minus 3, and then simplify that to positive exponents and so forth. Okay, any other question? Okay,
we can move on for now.
All right, guys, we continue now.
The guys are just asking for the question that you said they must do themselves. So I think it will be best for you guys to get the notes, because the question is on the notes.
Okay. Do you think you can just quickly go to the question and show them in a second? The question that you needed to do, guys, is this one, right? You can take it down. It's f of x equals to 3x squared minus 5x. So you're finding your derivative from first principles. Now, we know that it's not being asked that much in your CAPS document, okay, but it's still the same procedure. Okay. We continue. the next problem. We said in one of our rules is that we don't want to see the brackets there, right? So you need to simplify this thing first before you get your derivative. You've got 2x minus 1, and I kept on saying you must have x to exponent something, x to exponent something. So now this is 2x minus 1 to exponent 2. Let's fix that first. You've got your f of x equals 2. Now, what does the 2x minus 1 all squared mean? It means that you've got 2x minus 1 by 2x minus 1. So if you expand that, right, Abram, expanding, I'm sorry to say this, but then one of the learners said 2x minus 1, if you expand that, you get 2x minus 1, 2x minus 1. I don't know if you
I've seen that.
expanding in my language. Okay, so we don't expand it like that. Okay, guys, what does this mean? You've got 2x minus 1 by 2x minus 1, which gives us 4x squared minus 4x plus 1. Now, we have multiplied the 2x minus 1 by the 2x minus 1, okay? So now, next, we'll look at our problem. Okay, now it's x to exponent something, x to exponent something. Then we can change the notation. This is f prime x equals 2. Now, we said we take the exponent, we times by the coefficient, okay? So 4 times 2, that gives us 8. X to exponent 2 minus 1, all right? Now, there is a 1 there. So 1 times minus 4, you get minus 4, x to exponent 1 minus 1. Now we said the constant, the derivative here is going to be 0 because we had that x to exponent naught, okay? Right, now let's simplify this. We get f prime x equals to 8x minus 4, x to exponent naught. Sorry, now x to exponent naught is 1. 1 times 4, we get a 4. So that is our derivative there. Now, next, find the derivative of your dy dx. Okay, find dy dx if x squared y equals to 3x to exponent 4 minus 3x squared plus 12. All right? Now, the point that I want to stress here is that if they're asking you to find dy over dx, they want you to find the derivative with respect to x, and your y has to be the subject of the formula. If they're asking you to work at maybe dt dx, right? Here, your question will have your t as a subject of the formula. So you'll have something like this, t is, okay? And then x maybe to exponent 3 minus 2x plus 1, something like that. So for you to find dt dx, you must have your t as your subject, okay? And then you have x somewhere. And then your x has to be exponent something. It must not be the denominator or under the square root. Okay. Now, if we look here, is y our subject of the formula? No. Now, the y is being multiplied by that x squared. How do I get rid of that x squared? I'm going to divide by x squared throughout. So I'm going to divide by x squared on my left-hand side and also on my right-hand side. So that will be over x squared, and then this is all over x squared. Okay. Now the x squared divides the x squared. We get y equals 2. Now, earlier on we said, okay, we don't want to see the x as a denominator, but then all over x squared, what does that mean? Each and every term has got a denominator of x squared. So you've got 3x to exponent 4 divided by x squared minus 3x squared divided by x squared plus 12 divided by x squared. All right? Now, next, we're still simplifying, and watch grade 12s, we still have y as our subject of the formula. We have not yet gone to that other stage of saying dy dx. Okay, so you have y is, let's simplify that, x to exponent 4 divided by x squared, we get x squared minus 3, okay, because the x squared and the x squared divides, okay? So we have a plus. Now there is another problem here. We've got 12 divided by x squared, okay? We don't want x to be the denominator, we take it up, changes the sign, so you get 12 x to exponent minus 2. Now you see everything, it's x to exponent something, x to exponent something, and so forth. We then now can say, all right, this is now dy dx equals to, follow the rules again. You've got 2 times that 3, you get 6 x to exponent 2 minus 1, which gives us a 1. Now, what do you think this will give us? Minus 3 x to naught, then that will be 0 there because that's a constant. And then minus 2 times 12, you get minus 24 x to exponent minus 3. And then to make it neat, leave it to positive exponent. This is 6x minus 24 x to exponent 3. Okay. Now, any questions so far, or we still fine? Or we undefined?
Still fine. We're still fine.
Okay.
I'll give you.
Right. Guys, we've been doing functions and so forth and so forth. But now, in calculus, you'll be asked to sketch or draw the cubic function and so forth. In grade 8, you did a straight line. Y equals to mx plus c. You needed the gradient and also your y cut. And then you moved on to grade 12. In grade 11, you had your parabola where you need 2 x-intercepts and also a turning point, and you're using x equals minus b over 2a for a turning point, and then you take that and substitute in your original and so forth. Right now, this year, you'll be having a cubic function. Now, with your cubic function, it's in the form of ax cubed plus bx squared plus cx plus d. You will need to find 3 x-intercepts, 2 turning points, and also your y cut. Now, it is also on your notes. I am going to give you this question, right, to do as your homework. Then when we meet next week, we're going to be looking at drawing these functions. Okay, so you can take it down quickly. You sketch the graph of f of x equals to x cubed minus 9x squared plus 24x minus 20. You have to show all intercepts with the x's and any stationary points, with your turning points and so forth. And you may discuss them but then we're going to look at that next week. Now, guys, this is now going back to trying to find our x-intercepts. But if you're given x cubed minus 5x squared minus 2x plus 24, you need to solve for x, okay? You cannot take out a common factor, and there's nothing that can help us. What we can do is we look at your 24 and then your 1 there of the coefficient of x cubed, okay? So you look at the possible factors that when you sub in there, they will give you a 0. We'll be looking at different methods of finding x, but today I'm going to be looking at only your synthetic division, okay? Now, the factors of 24 can be plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, blah, 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 and then up to when you get to plus or minus 24. But then maybe the first 3, when you try them, then if they give you a 0, then that's going to be your factor. So now if we try 1, we get 1 minus 5 minus 2, it doesn't work, the minus 1, and so forth. But then if we try, for instance, 3, if you put a 3 here, you get 3 cubed minus 5 by 3 squared minus 2 by 3 plus 24, and then that's 27 minus 30, right, minus 6 plus 24, and this doesn't work out. I think there's some sign problem here. Abram, help me. That's going to be 27 minus, okay. Just doing it like you guys now. Okay, your 9 times 5, that's 45. Okay, now let's work it out. That's going to be 27 plus 24, that's 51 minus 51, which gives us as 0. All right. So now, x equals to 3 is a factor of x cubed minus 5x squared minus 2x plus 24. Now, the method that I wanted to show you is your synthetic division, whereby you take the coefficients. The coefficient of x cubed is 1, of x squared is minus 5, and then of x is minus 2, and then you've got 24. I am dividing by x equals to 3, so I'm going to sub it in there. The first thing that you need to do, although we're going to be looking at it next week in more details, you take the first number that appears, so the first coefficient down. What you do here is you say 1 times 3, you get a 3, and then when you come to this point, you do the normal addition, minus 5 plus 3, you get a minus 2. Then when you get here, minus 2 times 3, you get minus 6. Normal addition here, minus 2 plus minus 6, you get minus 8. And then the minus 8 times the 3, you get minus 24. Now, the 24 minus 24, you get a naught. Then this is now your x minus 3 bracket x squared minus 2x minus 8 equals to naught. Then that's your x minus 3 bracket x minus 4, x plus 2 equals to 0. Then you get x is 3, or x is 4, or x is minus 2. All right, so those are your x values when you are asked to solve for x in your x cubed minus 5x squared minus 2x plus 24 equals to naught. And now what I'm going to ask you to do is, if you want to confirm the x values and so forth, you can use a website called, you can go www.wolframalpha.com. Okay?
It's noted.
Is it noted?
Yeah.
wolframalpha.com. Okay. Yeah. I thought you wanted to say something.
No, I was noting your website.
Okay. All right. So your website is www.wolframalpha.com. You can confirm anything there. You can say, okay, draw the graph, blah, 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 blah. It can do everything for you. Can we go to that question where they're working?
Yes,
at
let's
home?
go to it.
Okay. All right. Guys, with your question, did they post the answers, Abram?
I think they think it's a homework as well.
No, these guys, they don't want to listen. All right, this question, you are doing it now, and then we confirm the answers. They're asking you to find the derivative from first principles. Now, I'm going again slowly here, all right? We said you can work it out first using the rules. So f prime x is 2 times 3, that's 6x to 2 minus 1, then you get a 1, minus 5x to 1, you get a minus 5. So whatever we are doing, all right, in our formula, we have to end up getting the 6x minus 5. All right, so you've got your f prime x equals to the limit as h tends to 0 of f of x plus h minus f of x, all divided by h. All right?
I think because of time, we're not going to be able to finish the question.
Okay.
So rather, they should post their answers on our Facebook page, and we'll give them the answer next week when they submit the homework.
Thank you very much. Thank you, sir.
That's simple, hey?
Okay,
All
sure.
right. Thank you so much, Sithe, and thank you guys for watching our show. It's been a great show. Do send through your questions and your comments that you still have about the show. We just want to express our greatest gratitude to the Department of Basic Education for making sure that we have this show for you guys. Really appreciate you. And up until next time, guys, remember, if you need more help on calculus, we have a video that we have posted for you. We love you, and peace.
Thank you. Cheers.